Hi everyone, I am Golden Actually. I am here to present programming beyond individual nodes in the course of ad hoc and wireless sensor networks. On completion of this video, students will be able to explain what is programming beyond individual nodes and its works. So, programming beyond individual nodes. Actually, sensor actuator network systems offer some unique advantages. Dense networks of a distributed sensor can improve perceived signal to noise ratio by reducing average distances from sensor to physical phenomena. So, in network processing and actuation, shorten the feedback chain and improve the timelines of observation and response. And to third, network nodes and infrastructure less mesh network topologies reduce deployment cost. However, the greatest advantages of a network the systems are improved robustness and scalability. So the decentralized systems is inherently more robust against individual node or link failure because of network redundancy. So decentralized algorithms are also far more scalable in practical deployment. So they might be the only way to achieve a large scales needed for some applications. So because of the decentralized system, spatial coverage and multiplicity in sensing aspect and modality. So the detection, classification and tracking of moving non-local or low observable event require cross-node collaborations among sensors. Okay, next one is tracking. Target tracking as a motivation example. So tracking is a canonical problems for sensor networks and essential for many commercial and military applications such as traffic monitoring, facility security and battlefield situations awareness. So given a moving point, a signal source or a target in a 2D sensor field, a tracking system's goal is to estimate the target state histories such as a spatial trajectory on the basis of a sensor measurement. So, from the tracking experts' point of view, each sensor node provides a local measurement useful in estimating the target state. So, however, in the most cases, only a relatively small subset of sensors contribute significantly to the estimation, moving to a sensing range limitations. In this case, a good solution is a leader based tracking scheme such as information driven sensor querying IDSQ to fuse information from only the sensor that provide high quality measurements. So for the most sensor types, moving to the physical properties of signal propagation, the sensor with a high signal to noise ratio will be within a limited range of the leader node. So we can minimize the communication cost and latency for gathering sensor data. As the target traverses the sensor field and the belief evolves to follow its motion. So the most informative sensors might no longer be those closest to the current leader. So a nearby sensor might then be selected to replace this leader on the basis of the updated belief and a criterion combining resources constraints with some measure of sensing utility. So such as mutual information. So the current leader then hands off the belief to this sensor, which becomes the next leader at time t plus delta, then where delta means communication delay. So the process of sensing estimations and leader selection repeats. So as a vehicle moves through sensor field, a nearby sensor detected and electrode leader node aggregates data from the active sensor and migrates the information from node to node as vehicle moves. So a sensor node collaborate primarily to improve sensing accuracy and acceptable estimation quality might be achieved using only the subset of the sensor. So one node the leader play a key role in fusing of others sensor measurements. So if no leader is present, all sensors that form the contour are equally important. So each node might locally update and repair its observation of contour section, but the global state can only be assembled from observations of many nodes along the entire contour. So, the system design must explicitly write code to maintain sensor correctiveness in a neighborhood, discover the best node for handoff, then invite neighbor nodes into group and handle communication delays and failures. Thank you. Thanks for listening.